Rate law practice questions. In the previous video, we went over a general concept overview for rate law. Now we're just going to look at a few practice questions to check your comprehension. Let's start with this first question. Times listed in the following table are required for this concentration to decrease to this many moles per liter per second. Let's have a look at this net reaction. Remember, when we are trying to find what the question is asking for, the rate law, we remember what our formula was. Our formula was rate number divided by another rate number. Both of these equal to their own constituents of particular slope. And we have x, z, and if there is a third one, we could put w or whatever variable you want. I'd like to use x, z, and w, but if you use a, b, c, that's fine as well. We don't need to put a third variable here because we only have two reactants over here, our S208 and our I. I'm doing the same thing on this side here. And for the exponents, again, you could put a, b, c, it's up to you, but I'd like to use m, n, and o. M, and there's no o, there's no third variable, so we're not going to add that. This here is our first formula, okay? And then our second formula in the previous video that we abbreviated was the rate law, and it's just rate is equal to whatever your slope is, and then you just get your constituent reactants. In this case, we're going to have x and z. Okay, so we're just going to be using these two. Okay, so this one has to happen first in order for our actual rate law, right? This is what the question is asking for, the rate law, which is this one here, number 2, in order for that one to be solved. Okay, we've got to use this one first. So let's have a look at which values for our rates, numbers, that we're going to be using. Well, always look for the trials that have the same concentration first, and then you'll be able to isolate for the unknown ones that are not the same. For example, we have trial 1 here, trial 2 here. These are the same. These, however, are not the same. Okay, we're looking at these two trials right now, 1 and 2. So because these are the same, that's awesome. This one is an outlier. We got to find that out, so it's perfect. Okay, in most other types of questions that you'll be seeing, you'll have 3 reactants, for example, okay, where 2 of them may be the same. So this one and this one will be the same, and then maybe another one here would be the same. Okay, we have 2 values that are the same here, 2 values that are the same here. Okay, it works the same way. You have to have at least one that is not the same. That way we can use that in order to figure out what the exponent would be. That's m and then n over here, what I'm referring to, the exponents. And then you got to do the same thing for the other ones to find their respective exponents for n and then o, etc. And then you'll be able to fit them all into here. If you have no idea what I'm talking about, I can see the previous video. The link is in the description, or just continue to follow along. It's up to you. So let's use this one here for now. We're going to use trial 1 and 2, okay? So I'm going to use 78 as my first rate number here. Oops, in seconds. And next trial here was 39, so that's going to be being divided. It's going to equal, again, both of these have k, right? The slopes, we don't have the slope, we don't have the proportionality constant. We don't know what it is, it's not given to us, so just leave it blank for now, just leave it there. And then we're going to be putting our reactants, okay? So we're starting with, again, this one here, which is trial number 2, right? We're going to go from left to right. We're going to go for our first reactant, 0.04. And then we don't know what the exponent is b, so we'll just put m, and then the one after that, again, it's another 0.04. And then those will be the second exponent, n, okay? That's it. So now we're going to be doing the next trial, number 1 down here. We'll do 0.04, m, and then the next one after that, left to right, is 0.08. There we go, that's it. So we're just going to start dividing these, right? So just divide this, divide this. What do you get? You also end up getting 2. And then here, they just cancel out perfectly, so nothing happens there. These cancel out perfectly, so there's just going to be nothing left. And then here, we're obviously going to get our 0.04 divided by 0.08. That's going to give us 0.5. And it's going to be to the power of n. How are we going to get 2? Okay, it has to be to the power of -1 here, obviously. So n to a -1. Okay, so then obviously you get 0.5 to the power of -1. That's going to give you 2. So it seems like our value here is going to be -1. So we've done it for the first one. Now we got to do it for the second one, okay? Because right now we only have the exponent for n. I'll just put it here. We have n is equal to 1, but we got to find m as well, okay? So we got to find m. So let's do that for another one. So let's use another one where these have to be the same this time, okay? So this one here and this one here are the same, okay? And this one here are different. Awesome. That's what we want. We want one set to be the same, one set to be not the same. So we're definitely going to be using 3 and 1 here, okay? Trial 3 and 1. So let's start off with 156 up here, divided by our 39. Let's put our reactants, again, left to right. We're going from 156, so let's start here, 0.01 to the power of m, here 0.08 to the power of n. We're going to do the same thing for trial number 1, 0.04 and 0.08 again. There we go. So obviously these are going to cancel, because what do you end up getting? You end up getting 4. This obviously cancels out, no problem. These cancels out, no problem. Then we're just going to be doing this, 0.01 divided by 0.04. You obviously end up getting 0.25. Okay, and this is the power of m. So what are you going to use? Obviously, it sounds like -1 is going to be working in this case as well. So 0.25 to the power of -1 is obviously going to give you 4. Now that we have our m values and n values together here, we're pretty much finished. All right, so that's it for that. Now let's find our rate law, what the question is asking for. So we can just put the rate law here. So rate is equal to our K, and then we got to put our reactants. Okay, so our first one over here, our X is going to be S2O8, 2 minus. Okay, and then our second one here is going to be technically our Z, but it will be I1 minus. And we're just going to put our exponents on top, right? So this one would be m, right? Technically it's -1. We found it out, so this is -1. And then this would be n. We found it out to be -1, so it's now -1. This here is your rate law. I know that's what it's pretty much asking, but the question also has this in a question mark, okay? So I know it's not listed in the question, but let's just do it, okay? Let's find what this value is going to be. Okay, let's figure it out. So if I do my rate this way, and I use all of these constituents for our trial number 4, here's the problem. I can't find my rate because this is unknown. That's this one over here, right? If I just do my first step to find my slope, I have no idea what it is. It's not given. Then even if I do all my reactants, right, my S2O8 value here and my I1 minus value here, if I do that and put the exponents up here, it doesn't matter. I cannot find my rate because this one here is unknown. Okay, so how the heck do I do this? Well, I obviously have to find my K. So how do I find my K value? Well, in order to find K, I would have to use any example over here, any trial, it doesn't matter. As long as I got my exponents, I'm good, okay? As long as I get my exponents, I can use any trial. Okay, I'm going to use number 3 here, but you could use these ones too. Okay, number 1 and 2. I'm just going to use trial number 3. Okay, so let's give it a try. So I'm just going to quickly erase this out over here and draw it out using trial number 3. Okay, so trial number 3, we're using this one over here, so 156. Okay, and this is in seconds, and we have to use K. We don't know what it is, it's all right. And then we're going to put our initial values. Okay, so 0.01. 0.01. Okay, and then this is obviously to the power of -1. And then I'm going to multiply by my 0.02. Oops, sorry, not 0.02 here, 0.08. And this is also going to be -1. Let's multiply these together. What do you end up getting? 1,250. Okay, and then this one, you're just going to bring it down here as well. And all you're going to do is divide this, and then what do you end up getting for K? You end up getting 0.1248. There we go. That's the answer for K. Okay, so now that we found that, we have to eventually put this back into our rate law formula. So that's this one over here. So let's put it together. Rate is equal to, now I know my K, it's going to be 0.1248. And then I have to multiply it by my first reactant over there. The reactant here, again, we're looking at trial number 4 because we're trying to find the rate for trial number 4. It's 0.02. Okay, we know it's -1, and then we know that this one's going to be also 0.02. Also to the power of -1. What do you end up getting? just do your little calculation. I'm getting 312 seconds. That's going to be the rate. So that there is your answer. We found our rate law, which is this one over here, and we found our rate right over there. Determine the rate law and calculate the rate constant for the following data. I want you to try this one yourself. Please pause the video. I am going to show you the answer, but I'm also going to take a little guide throughout the answer just to make sure that everyone has this, down packed. And then I'll give you an actual green question of the day question at the very end of this video. All right, so hopefully you've given it a try. I'm going to give you the answer breakdown right now. So we're going to start looking at values that are the same, okay? So we're going to be using this one over here because first we got to find, well, I know we're just using A and B here, so maybe I'll just use A and B. I usually use X and Z, okay? But for some of you, if you want to see it as A and B, we can do it this way, okay? I'm just going to keep my exponents as M and N. Okay, I like using M and N. And then same thing for the next rate. Okay, same thing, M and then N. Let's give this a try. We're going to start with these two that are the same. Okay, I know that technically this one and this one are the same too. Okay, but I'm just going to use trial 1 and 2. They're right beside each other. It doesn't matter. Okay, you can use other ones if you want. I'm just going to use 1 and 2 for now. So these are the consistent ones. They're the same. These are obviously not consistent, so this is perfect. Okay, we have one that is consistent, one that is not the same. Let's use that in order to find the exponent for B. Okay, so obviously for B, it's going to be the N exponent, and then A is going to be the M exponent. Okay, so let's start with this one here. Let's start with our first rate. Okay, our first rate for number 2 is going to be 0.52. Okay, so 0.52 times 10 to the negative 9. Okay, oops, sorry, moles per liter per second. And this is all going to divide by our next one, 0.26. Which is going to be moles per liter per second. And then we're just going to put our K values. Okay, we don't know what they are. It's okay, we'll just leave it the way it is, no big deal. And then we're going to put our first reactants. Okay, so trial 2, our first reactant is 1 times 10 to the negative 3. Okay, and then our exponent, okay, we have no idea what it is, so I'll leave it up there. Then my next one after that, going to the right, is 0.50. There we go. And this is going to be to the power of n. I'm going to do the same thing for my next one, right, which is 1 times 10 to the negative 3 as well. And then the next one's going to be different, 0.25. There we have it. So I'm just going to divide accordingly. What do you end up getting? I'm getting 2 over here. These cancels out, no problem. Next, what I have, these cancels out, no problem. These obviously don't cancel out. Let's just divide it. End up getting 2. Okay, to the n, obviously n has to be 1 over here. So we found our n value, so I'll just put it here on the side. N is equal to 1. So I've done it for my n. Now I got to find my m. Okay, so let's try another one. So let's put it on here on the side. Let's do, what do we have here? We got technically this and this are the same, right? And these are different. So let's just do that one. Okay, let's do 3 and 4. So this and this, same as together, and then these here are obviously different, so let's use that one. So now let's use 3 and 4. So let's look at our first one. Our number 4 here is going to be 4.16 times 10 to the negative 9 moles per liter per second, and it's going to be dividing it by 1.04 times 10 to the negative 9 moles per liter per second. And then I'm going to use my K values here. And what do I get next? I end up getting my next reactant, okay, on trial number 4 is 2 times 10 to the negative 3. 2 times 10 to the negative 3, okay, and that's obviously going to be to the m. And then next one I got 1 times 10 to the negative 3. And this is going to be to the n. Next, for trial number 3, below that is 1 times 10 to the negative 3m, and then after that again 1 times 10 to the negative 3 n. Okay, so let's divide accordingly. Let me know what you get. You end up getting 4 over here, and then this side, these cancels out properly, these cancels out properly. Obviously we're just left with this, so what do you end up getting? end up getting 2. Okay, to the m, obviously m here has to be 2. Okay, so we found out our values for our exponents. Okay, n is equal to 1, m is equal to 2. Now, what is the question asking for? Determine the rate law. Okay, same thing. Let's look for the rate law. I know this is our first formula. Our second formula, you should already know it, but it's rate is equal to your K, and then your reactants will be A, and then your next one, which will be B, and then you just got to put your exponents up there, and we know what our exponents are. We have m as 2 and n as 1, so I'll just put it up there. There we have it. Okay, this here is our rate law. Okay, but what is the question asking for? Question is asking for rate law. We've done that, but now we got to find the rate constant. Okay, so we got to find our rate constant. So our rate constant is obviously K. So how do we find K? It really doesn't matter which value you use. Okay, it doesn't really matter any. You can use any trial. Again, as long as we find our exponents, we are good. We could use any trial here. It doesn't really matter which one you use. I know we've used 1 and 2 so far. Okay, we've used those 3 and 4. So I'm just going to randomly choose number 5. Okay, just to prove that it doesn't really matter which trial you use. As long as you have your exponents, you are good to go. Okay, so let's use this one here. Okay, we'll use trial number 5. So we'll have 9.36, and we're just going to follow this formula over here. So we'll get 9.36 times 10 to the negative 9, and then you have your K, and then you have your A. Okay, what your A is going to be. Okay, your A in that trial is going to be 3 times 10 to the negative 3. Okay, and this is going to be squared over here. You're going to multiply by b. You get 1 times 10 to the negative 3. You're going to put it to the power of 1. And I think we're done. That's it. Okay, so we're just going to figure out our values here. What do you end up getting over here? Getting 9 times 10 to the negative 6. And then over here, you end up getting just the same thing. I'll just bring this down again. Okay, so obviously you're just going to multiply these together. What do you end up getting? You're getting 9 times 10 to the negative 9. Here, just keep bringing it down. And then divide this accordingly. Divide this by the same. And then what do you end up getting for K? You end up getting 1.04. Okay, that's your answer. This here is going to be a rate constant. Okay, so this here is your rate law. This here is your rate constant. This here is your green question of the day. Please pause the video, give this a try, and I'll be giving you the answers shortly. This here is the answer.